there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
And welcome to the elementary edition of Count on Us. I'm Miss Shirey.
Mr. G in the place to be. Happy New Year. Woo!
Happy New Year to you all. This is the first time we've been on this New Year.
Yes, it has.
Wonderful. It's a cold and snowy New Year. That's what it is. But we're having a great time here working on some math, and I hope you are at home working on your homework. I know your teacher's giving you some homework because it's so cold you really can't go outside anyway.
There you go. And the snow's gone.
It is. It's like cold with no snow. That's just really, there's no point to that.
That's painful.
I know. But at least there's math. There's always math to do.
There's always math to do.
There's always some math. So give us a call here, 301. You know the number, 772-0080.
I almost forgot. It's been a while.
It's been a while. See, you just have to refresh yourself.
Okay.
We're here awaiting your call, just waiting to help you with your math homework. But until then, we have some challenges. We do have some challenges.
Oh, we could go with the challenges.
Mm-hmm.
Our first challenge is 24. I love challenge 24.
Love
You
it.
have to take the 4 numbers and compute them to equal 24. So we have 4 cards here. The first one, card A, is 7883. And I already have the answer to that one. B is 8851. And I already have the answer to that one. And C is 4865. And D is 3794. So you can take on the challenge after you give us your homework problem and we work that out. You can take on the challenge and see how well you do.
We also have another challenge.
We do? Oh my.
Yeah.
Oh my. Let's see.
We have a word of the day. Word of the day. There it is.
Cold is the word of the day.
That would be the word of the day, but no, it is not. So we have a different word of the day, and what you have to do is call in with some yes or no questions for us, and we will help you keep track of them, and hopefully you will be able to come to the conclusion of what the word of the day is.
Frigid.
Ah,
How about that?
That would be great. How about polar vortex?
Polar vortex. That's 2 words.
Yeah, that would be kind of hard. But anyway, those are our challenges for today. So write them down, think about them, and work on them during the show and call in. And we would love to hear your answers to the challenges, especially the challenge 24. There's always more than one way.
Always more?
Always.
Always?
I think there's always.
That's an open-ended problem.
I've never met a card, a challenge 24 card, that there wasn't at least 2 ways.
Really?
Yeah.
Okay, because, once I find my way, I'm done.
You're done? No, you have to have some perseverance. You have to keep working.
Well, once you get the answer, I'm done.
But maybe there might be a better way. Maybe there's a more efficient way.
Maybe. Okay.
That's my word of the year, efficiency.
Efficiency. Okay. Okay. Well, my efficiency might not be your efficiency.
Oh, maybe not. Maybe not. True. I'll
we have
give you that.
different ways of figuring things out.
That's right. But there's always, I want to say, always with those, there's more than one way.
Okay. More than one way.
More than one way.
That doesn't mean my way is not as efficient as yours.
True.
It's efficient for me.
Well, let's work on some problems, and we'll see whose way is more efficient today.
Okay. All righty then.
So, what can we work on?
Woo!
And I'll tell you what's more efficient. I bet I'll find the more efficient way.
Yeah?
Yeah.
Is that a challenge?
It's a challenge,
Oh my
Mr.
goodness.
G.
I'm ready to do 24 challenge to see who's more efficient.
No, let's do a problem. Like,
Okay.
for example.
Okay.
Okay, this
Your
is what we were
example.
doing today in 2nd grade. Say we were adding 299 plus 83.
Whoa, that's a whopper.
Uh-huh. Now, I bet you have a way to add that up.
I do.
But I have an extremely efficient way to add
I
that up.
have an efficient way.
Okay.
I can decompose numbers.
What?
Break them up.
I think you are so copying my efficient way.
You didn't say anything.
Hey, you're
I'm a mind reader.
Okay.
Now,
How are
This
you gonna
time we
solve it?
might have the same efficiency. So 299 is 1 away from 300.
Yep.
So what I could do is I could break this number up into 82 plus 1. That's still 83. And I could take that 1 and add it with the 299 and come up with 300, and then I can add the 82, and then it's real simple. I don't have to figure out all these complicated numbers here.
Nope.
So
No
that
regrouping.
becomes 382.
Wow.
Now, I think that way is efficient, but you could also do 299 plus 83, which is cool, but what happens is you have to do a whole lot of trading.
Yeah.
So then you have 9 plus 3 is 12.
Okay.
And only one number can go in that place. So the 2 from the 12 goes in the 1's place.
Leave
The
your ones,
1 from the
sure.
12 goes in the 10's place.
Okay.
And that's 9 10s, 1 10. That's 100, 180. But we can't put the 100 and the 80 there. So we can put the 80 and the 8 goes there because that's in the 10's place. And then the 100 goes in the 100's place. And 100 plus 200 is 300.
You get the same answer.
Ooh, ooh,
But I think our way is definitely more
ooh.
efficient.
Oh, our? Are you claiming my way?
Yes, that's what I was thinking. That's what my kids were working on today. This was a review. We were working on some. But today I made them create their own problems. And they were pretty good at it. They had to come up with a problem where that would be a very efficient way.
Very good, very
Yes,
good.
I was quite impressed with my second graders.
Okay. Well, you know, I was working with second graders today as well.
Awesome.
But what I did was I had them working with the base 10s so that they could see anytime you have 9 in the 1's place and you get 1 more or more to that 9,
Yeah.
then you can change the 1s for a 10.
Oh, you can trade.
You can do that.
You can regroup them.
You can do that. And that's what we're actually doing here.
Right.
A lot of times we don't know what that looks like. So here, that's what we did. We traded. We had 12 1s there.
We did have 12 ones.
So we took 10 of those 1s and put it in the 10's place. So now we're just left with 2 1s. And then since we had 9 10s and 8 10s, that would give us 17 10s. And one more 10 is 18 10s. Out of that 18 10s, the 8 is a 10, but the 1 is 100. So we were doing that with the base 10 blocks over and over. We did like a game to 100.
Excellent.
And every time they had to move the base 10 blocks from the 1s to the 10s to the 100.
Oh, okay, okay.
And that was cool.
We're kind of moving past using the manipulatives. I have them draw them out because sometimes we don't have a lot. It's hard to find that many when you get to the bigger numbers. So we're practicing drawing them out now, and they're doing a good job with that.
Okay, that's
like
a big
this
number.
one.
You
Can
would
we draw it out?
draw that for 299?
Yeah, let me show you. We can draw it out.
Please.
So let's say I use big squares for the hundreds. So 200, 10, 20, 30, 40, 50, 60, 70, 80, 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how we draw it out. 299. And then we had to add 83. 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3.
Gotcha.
So if they draw it out, one and then the other one underneath it, it becomes very easy to trade.
Okay, so then I could take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them and make that into one of these now, right? And then I can like get rid of that.
Yeah, you could. We could get rid of it.
That way I'm not confused by it. Ah, yeah.
There we go. But don't take off those last two.
I'll take off the last two, but then I can do the same thing here. 1, 2, 3, 4, or 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. How about I take this and put it up here? So now I have another 100. That's not a perfect square though. So that's 100,
okay.
200, 300, and 10, 20, 30, 40, 50, 60, 70, 80.
So you
that's
can do 300 plus
80
plus.
2.
Yep.
And keep them there. And then
Put
you
them
have
all
the
together.
300, the 80, and the 2. Oh,
And that gets us the same answer that we got over here.
Exactly.
Now this is the Y, but this is definitely more efficient. Once you understand how this works with trading and what it means, definitely the kids are ready to move on. So if you know what this means, it's definitely more efficient to do the other method.
Yeah, I got you. And you definitely wouldn't want to do 100 little dots because that would take forever.
It's totally not efficient at all. No.
I agree. I agree.
So we were working on a whole bunch of different things today. In fact, some of the problems I really liked. Like we did one problem where we were talking about adding, but they were kind of tricks because we've been doing so much adding that then we got to this problem where they thought they're just supposed to add the numbers in the word problem. And that's not always the case. You have to go through and make a plan. You got to figure out what they're asking you.
You have to understand what the problem is asking.
So it said there were 428 pumpkins at the farm.
That's a lot of pumpkin pie.
Yep. And then somebody came and they brought some more pumpkins.
Ooh.
Yeah.
More?
Yeah, they brought some more pumpkins. And then at the end of the day, there were 580 pumpkins. And some of my kids said, we're just going to add them together. No, the question was, how many pumpkins did they bring later in the day? Not how many pumpkins were in all, because they told us how many pumpkins were in all. So this was the total. This was the AM, that was the morning. And this was PM, that was the afternoon. So they wanted to know how many did they bring in the afternoon. We already knew the total, so adding these two was not going to give me a total.
Right.
So they kind of like doing that because we talked a lot today about the unknown. You could write an equation for this story like this.
Oh. You know what I do? I always do this. I do part.
Oh. Wow, that's excellent.
So I know one part. I'm missing a part, but I know what the whole is.
Yep.
So then I can use the information that I have here to find out what the missing part is.
Yeah. Now, once they knew that they were missing a part, my kids are good at saying, hey, I know the inverse of addition, and it's subtraction.
Your second graders say they know the inverse of addition?
Oh, yeah.
I'm
it's
impressed.
The smart class.
I'm impressed.
And they knew that you can just subtract and find the difference. You can find the missing part.
Is that
because
SAT?
Small plus small equals big.
There you go. There you go. Is that an SAT word?
What? Big?
Inverse.
Inverse? I don't know. But whatever, it works. So then we can figure out there were 160 pumpkins that people brought.
Okay. Can we check that?
You could. You could check it. You could use the inverse to check.
Is inverse the opposite?
Yep.
Okay.
It's the opposite. So then we could just add it. 0 plus 0. 6 plus 2. You don't even have to regroup in this one. It's so super easy.
Wow.
Yeah. If you put the parts back together, you should get the whole that you started with.
I like that.
Now, we also did another way. We did a number line.
You did? You did a number line as well?
Yeah, we like number lines. My kids like number lines, and they're getting better at them. So if we did the same, we actually did the same problem on a number line. So we like blank number lines because they open up our mind. They free us to be creative. So my kids like to start. You start with a small number. They said they were at 420, and by the end of the day,
go all the way to 580.
580.
Oh, so if it's blank, you can put in the numbers that you need.
Yep. Yep.
All right.
Yeah. So they started. Well, a couple of them started different ways. Some of them started jumps of 10, but some people did jumps of 100. So if you jumped 100, you don't have to jump by ones on a number line all the time.
You put 100 there.
Yeah.
Then you just have to figure out to go from 520 to 580.
Right. 20, 30, 40, 50, 60, 70,
my
80.
tens, yeah.
Now, my spacing isn't very good, but if I do a jump of 10,
bumps.
10, 10, 10, 10, and 10, I can count my hops, and I can figure out that this really is a jump of 60. And they can
And
figure that out.
altogether,
A lot of kids
100
like to
plus
do the
60.
shortcut. They like to do a jump of 100 and jump of 60. They like to take the shortcut. And then you can figure out how many spaces did you jump? 160. Yeah. So I love the blank number lines.
That's a nice method there.
Yep.
I like that.
Yep.
I'm going to have to try that out.
It's excellent. It's a great way. Kids love it. Because I tell them you can have freedom. You can jump by ones, tens, hundreds, or they like to get creative. Sometimes they get too creative. Sometimes they start jumping in twos and threes, and it's really not the most efficient way,
Okay.
Mr. G. So,
But I like creativity.
yeah, we like to be creative, but we
Yeah.
also like to find, we always argue about whose way is the most efficient. We talk about what does efficient mean. Like, is it always the fastest way? Or which way, sometimes being the most efficient way is not always the fastest. Sometimes it's being the easiest. So, anyway, that's a great method.
I like that. I like that a lot.
Awesome.
Ooh-wee.
So what else did you do today? What else can we talk about?
I did a lot of testing stuff. So
Oh, a lot of testing.
yeah,
Oh,
I did all
no.
that kind of stuff. So I didn't get to do a whole lot of math today.
Oh, I'm sorry.
So
We always do math. We are always working on math. We did a lot of problem solving today. What other kind of problems did we do? We did a lot of unknowns. A lot of the same kinds of problems.
unknowns.
Yep.
You have that part whole going on, or whole part.
Yeah. So, like, for instance, if we had 40 candies, and Mr. G had 40 candies. And then total, I know that there were 160
Oh, you
candies.
didn't give me all that candy?
No, that's the total.
Wee! I'm in
But
trouble.
what you have to do is guess how many candies I had.
Do I get to keep them once I figure out how many that you had?
No, because I left them at home. I didn't bring my candies. You got 40 candies, and I know that we got 160 candies.
Okay, can I try your method? Can I try? I want
Sure.
to try the method that you use with the
number line?
The number line.
Okay.
Yeah.
I love the number line.
Okay, so I have number line.
Yep.
Start off with a blank number line.
Love them.
Woo-wee. And I started with 40 candies. Mine, all mine.
Nope.
And we ended together with 160. And I want them all.
You can't have them all.
So I can go from 40 to 140.
What?
Yeah.
Yes, you can.
So that's
In one
100 in one jump. And now all I have to do is 40 to 150, 50 to 160. That was a little big. Yeah, that wasn't quite even there.
It's all right. You can make them even. There you go. Much better. Much better.
There you go. So that's
We're working on the evenness of our bumps. In second grade, that's really kind of hard.
cool. So 100 plus 20 is 120.
Wow. Excellent.
I like
I'm
that.
impressed.
I like that
You
method.
give me my number line.
Ew.
The number line method is very good for showing people how you got your answer, but I don't find it to be very efficient. It's a lot of work. Depends on what kind of visual
you know
want.
what? If you're an art type of person,
I guess it is.
artistic, and
if you're
it makes
artsy.
sense to you, because a lot of times we have to show our work, and I think that's a good explanation.
Oh, it's a great explanation.
Yeah, so
But I'm always about mental math. Anytime you can do stuff mentally, I like that.
that's true, but a lot of times we're going to have to justify our work, and you can't always justify it mentally. Ha ha ha.
Ha ha ha. True. Yes.
So if I can show a strategy like this, and I thank you for showing it to me, now I can display my work, and that's my thinking on paper.
Excellent. Well, I'm glad I could help you today.
Yeah.
I love that method. That's a great way.
We'll try
Great,
that.
great.
You think I can try that in the grocery store tonight when I go? And
Sure. You can try it anywhere.
Have
Just
a big
bring your
number
notepad.
line?
Yeah, just draw number lines all over the place. Number lines, number lines.
$4.99, $5.20, and just keep making money.
Just keep on jumping.
Yeah, okay. That works.
So you were doing testing. I was doing problem solving with unknowns and number lines.
Well, I
else
know
can-
students are still struggling
Yeah.
with fractions.
It's always fractions. But
Always
fractions are just
fractions.
parts of a whole.
They are.
Sometimes you have so many parts that makes more than a whole.
That's true. That's true. What's that called again?
Improper fractions?
I don't like that.
I don't like it either.
What's improper about it? It's
don't
still
know.
a fraction.
And it's not improper. It's nothing improper. It has manners.
As manners.
It has manners. It's not improper.
Okay. So you have an example of one? Let's see.
Well, how about fourths? How about like 7/4?
7/4?
Yep, 7/4.
7/4.
Yep. 7
So-
fourths. I ate 7 fourths of the brownies.
So let's see. If I had one whole, and I broke that whole into 1, 2, 3, 4 parts. 1, 2, 3, 4. And I had another almost whole,
Almost.
and I broke it into, well, if I had another whole and I broke it into 4 equal parts. And I kept counting. 5, 6, 7. I can take that off. I call these all fourths because it was a whole. Yeah, doing it in black. I had one whole, and I broke that whole into 4 equal parts. So if we just count the parts, 1, 2, 3, 4, 5, 6, 7 fourths. Or we could say that it's 1 whole and 3 out of the 4.
Ah, we could.
You agree?
Yes.
So 7 fourths is the same as 1 whole and 3 fourths. 4 fourths in there, 3 fourths there.
Very good.
I like that. I like that. I like that.
I like your representation. That's cool.
You like my picture?
Yep.
Yeah. Representation, that's another one of those big math words.
I know, representation.
Yeah, we have to get comfortable using our math terminology.
Yes. Well, my kids are very used to it because we use it all the time.
I
We're always
believe you.
arguing over stuff too. I like arguing.
Debating. I
Math.
don't like arguing as much as debating.
Debating.
Justifying.
Justifying your answer. That's
there
right.
you go. We can critique each other's work.
Well, how
but
do
then
I know? How do
justify
you
it.
know that these numbers are right though? If you didn't have this picture, how are you going to justify to somebody?
Well,
How do you figure out this to this?
I could.
How do you
I
know
could
that?
because what I do know is, if I take 7 fourths, I know something called a whole fraction. If I take out a whole amount, which would be 4 fourths, which would be 1 whole, that is equal to 1. And then what's left over is 7 minus 4 is 3. And the 4 doesn't change because that's what they are. They're
Right.
called fourths.
They're
It's like a
called
last name. I would
Yeah.
say it's like a last name. So 1 and 3 fourths left over. So this is my 1 and this is my 3 fourths.
Awesome. Yeah, because this is like a
could.
fancy one. That's all it is. It's just like a fancy one.
There you go. There you go. See, you have more artistic ability than I do.
Da-na-na. That's why I like the number line way. There you go.
Oh yeah, you could do that on number line, huh?
Sure you can. You want to do fractions on a number line? We can do that too. Let's
You
do
can do it on a
fractions.
continuous number line, huh?
Oh my goodness, you're getting way too excited about the number
So
line.
I like this because you can make the blank number line, right?
You can.
Woo-wee! Okay, and then we can have 1 whole,
Yeah,
right? That would be 1, and then we could just start at 0,
yeah.
and then I could take this 1 whole and break it up into 1, 2, 3, 4 equal parts. 1 part, 2 parts, 3 parts, 4 parts.
Perfect.
And I can name each part.
You could.
1 fourth, 2 fourths, 3 fourths, 1 whole, or
4 fourths.
4 fourths. Then I can do it again. I have another whole here, and that would be
2.
2. And then this would be broken again into 1, 2, 3, 4 equal parts.
Excellent.
And then this would be 1 whole and 1 fourth, 1 whole and 2 fourths, 1 whole and 3 fourths, or 2 whole.
Look at that. Look at that. And look at that. And I can come in and go 1, 2, 3, 4, 5, 6, 7. That's how we can
It's the
get
same
7
thing.
fourths right here. Look
Okay.
at that. Excellent.
7 fourths.
Yeah, I like the number lines. They're awesome.
Yeah.
You can do anything with number lines.
I like that. Or we could rename this 5 fourths.
You
We can
could.
name this 6 fourths,
Uh-huh.
7 fourths, 8 fourths.
8
We
fourths.
can make them all fourths!
Make the whole world to fourths.
Make the world full of fourths.
That would not be so good. No. No.
That might be a good idea for a book.
The whole world is fourths?
Yes.
Oh, excellent.
Yes.
Okay.
I'm going to write a math book on fourths. You've inspired me.
Okay, great. I'm glad. Now, can we do some more with fractions? Can we do like dividing fractions?
Dividing fractions?
Yeah, and like why do you have to flip and multiply? Like why do you do that?
Ooh, you want to do that?
Yeah. Why do you flip and multiply?
Ooh.
Like I saw this great visual for this. Like let's say we had 3/4 and I wanted to divide that in half. 3/4 divided by half. How many halves are in 3/4?
How many halves are in 3/4? Oh my goodness.
No, that's kind of
That's
complicated.
a challenge.
Right, because see, most people write it out this way, but really, you can write it out this way as a complex fraction.
Woo-wee! That's division, division, division.
I know, and that's why it gets really messy. So that's why you have to flip and multiply.
Okay, so flip and multiply meaning you would keep 3/4.
Yeah.
You would flip 1/2
Yep.
to 2/1
And multiply.
and multiply.
Yeah. But
Okay,
why
so
do we do that?
you're doing the opposite here.
Yeah.
And I guess if you do the opposite operation, then you have to flip those around.
Well, look what happens. Really, this is very messy, isn't it?
It is.
So if you make the bottom one whole or
Ooh.
1, and we can just get rid of that, and that'll be nice and neat. But we know with a fraction what you have to do to
Whatever
the
you do to
denominator.
one, you do to the other.
Yep. Look at that. Then these
So they
cancel each other out.
and then you have a multiplication
One
problem.
whole. Yep.
That is so algebra.
Yeah. Isn't that cool? I love it. See, so it's really not that hard. That's why you have to flip and multiply when you divide.
Yeah,
Just
because
because
that was
it
getting
gets rid
scary with the
Ooh, it
division,
gets really
division,
scary.
division there.
Yeah, it's not necessarily. It's just easier.
Ah, so
easier.
you have to know that inverse stuff you were talking
You have to know the
about
inverse stuff. That's kind of like why you have to move the decimal when you divide decimals. Yeah, because it just makes it
That
easier to
makes so
think about.
much sense. And you know what? I know you could do this 2 different ways. You could say 3 times 2 equals 6, and 4 times 1 equals 4, and then you have that improper fraction, and then you have to change that to 1 2/4 equals 1 1/2,
Or you can take a shortcut.
you could say 2 and 4 have a common factor of 2, and simplify. 2 divided by 2 is 1, 4 divided by 2 is 2, and 3 times 1 is 3, 2 times 1 is 2, and 3/2 is the same as 1 1/2, and that's a little bit
You have to
quicker.
simplify, but it's still, yes, it's definitely more efficient.
I like that.
Yeah, awesome.
I like that because when those numbers get big,
Oh, it's so complicated.
That
I don't want to
gets
multiply all that stuff out. It's super ugly. That's why you have to flip and multiply, because it's just easier to think about.
yes.
It's a great
yes.
algorithm to have.
Yes, that's a good one.
Yeah.
I'm gonna have to remember all this stuff. Can I take notes?
You can take notes.
I don't have any.
I need to take
I don't
notes
have
from
my
you.
math journal to write and take
What?
all
You're
this
so
down.
unprepared today.
Oh my
so
goodness!
unprepared.
Oh, bad, Mr.
Well,
D.
I think we're going to take a break.
Taking a break.
Yeah.
I want more math.
I know, but I think we might have some callers later.
Think so?
we got to take a break
Okay.
and come back.
All right. Okay.
After the break,
All
stay
right.
tuned. We'll be right here. We're taking a break, but we'll be right back.
Have a snack and come right back for more math.
See you
Count
soon.
on us.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
Does retirement have to wait until my 70s?
Is a great college for our kids?
Out of the question?
Is the American dream
Out of our reach?
Not if we can help it. We're the National Endowment for Financial Education, a non-profit organization dedicated to helping people just like you get smart about their money. Log on to smartaboutmoney.org today and start taking control of your financial life.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back
from having your snack. You could still have your snack, but we're here for math. Are you going to call us? We're here waiting patiently to help you solve your math problems. We are here, we are here, we are here. Like Horton Hears a Who.
That's right.
We are here, we are here, we are here.
I think everyone was testing today. Maybe they don't have any math homework.
You think?
Maybe. I still gave
Goodness.
homework.
I can't imagine.
I always give math homework.
No homework? That's the trade-off?
Oh,
Testing and no homework?
can't deal with no homework.
Oh my goodness.
got
But
homework.
still, you still should practice.
You should. You should
Should be
practice.
online, going on First in Math and practicing
Absolutely.
those facts, all that wonderful stuff that students have.
That's right.
They can go online to the textbook, all that good stuff.
A lot of resources out there.
An amazing amount of resources.
You should be a math expert by now.
Absolutely. What I tell
you should
every
just be
group,
an expert.
I tell every group of students, if you're in the 4th grade, you are an expert in kindergarten, 1st, 2nd, 3rd grade math.
That's right.
If you're in 5th grade, you should be an expert at kindergarten, 1st, 2nd, 3rd, 4th grade math.
Wow.
And
yeah.
on and on and on.
Absolutely.
Every
I agree.
grade, you should be an expert of all the math
all
before.
the math before, all the previous
Ah,
math.
That's
Yep.
that's my opinion.
But you should be.
I mean,
You should have
I
had
think
enough practice.
Right. Right.
Well, you were going to show us something else.
Well, you know what? I noticed a lot of students struggle sometimes with adding and subtracting decimal numbers.
What? That's not that hard.
Well, if you don't line them up.
Oh, if you don't line them up, you need to remember your place value. I see. Okay.
Sometimes people don't line them up, and they
Okay.
put the numbers wherever they want. So let's say they have 3 and 1400ths.
You have to
I
wait.
just heard somebody's calling.
I know.
Somebody's calling. Somebody's calling.
My goodness.
Hello. Is anyone there?
Hello. Who is there?
This is Kyla.
Hi, Kyla.
Hi.
How are you? How are you?
I'm good.
Good. I need you to turn your TV all the way down.
It is.
It is? Okay. So, Kyla, what school are you calling from?
Glen Arden.
Glen Arden. And what grade are you in?
3rd.
Yeah, I like third grade. And what is your question today that we can help you with?
I want to know what is 10 divided. I want to know what's 12 divided by 10.
12 divided by 10. You have that for homework, or that's something that you just want to know yourself?
Okay. Hold up. Yes? Hello?
Yes, Skylar.
So, I need to know what's 12 divided by 10 for school.
Oh, so that was something that you had in class?
Not really.
Yeah, because that's a little challenging. So what happens here is you have 12 and you are sharing them or divide them up amongst 10. So do you know what that looks like?
No.
Okay, so have you done division like that before?
No.
So what happens is 12 is inside our little, what do you call it?
I don't know, but I call it a garage.
Garage, there you go. In the garage and out of the garage is the 10.
Okay.
So what you're doing is you want to share this 12 with this 10.
All right.
So what some people say is this number goes into. I don't say it goes into because it's sharing. So it's not going into, it's sharing it out. So if you have 12 pieces of candy, can you share them with 10 people?
What?
If you have 12 pieces of candy, can you share them with 10 people? Kyla? Kyla? Yoo-hoo! Are you there?
I can't hear Kyla.
Kyla?
Uh-oh. I think we lost her. Did we lose her?
Who's there
Hello?
in TV land?
I can't hear anybody. Oh, no.
Kyla?
I'm not on right now.
Uh-oh.
Kyla?
I don't know.
Who am I talking with?
I can hear the TV. Okay, well,
Okay,
we'll just keep going.
So we have 10 here, so we can share 12 with 10. Everyone will get 1. And we have shared out 10 of them, and 2 will be left over. So she said she was in 3rd grade. So, Kyla, that means that you have a remainder of 2. So 1, everyone will get 1, and you have 2 remaining that cannot be shared with the 10. So there you go.
That's kind of tricky.
It's kind of tricky.
Wow.
In our upper grades, they're doing that, and they're turning that into a decimal.
Oh, okay.
Yeah.
That's doable. All right.
That's very doable.
But I think we have another call.
Do we?
I think we do.
All right. Hello out there in TV land. Who are we speaking with? Are you there?
Hello? Hello?
We are here. We are here. We are here. Are you there?
Cannot hear anyone. Oh, no. No one wants to speak to us
They're
today.
teasing us today.
I know. They're out there. I know they're out there.
Give us a call.
Oh,
And
okay.
stay on the line.
Well, maybe
Anyone
we
there?
can you work on your other problem until we get someone back?
Well,
'Cause
it
I
looks
don't
like
see
someone
anybody.
else is there.
Hello? Hello? Hello?
Glenn Arden is calling us.
Glenn Arden. Lots of calls from Glenn Arden. Hello?
Are
I
you
don't know
there?
what's going on the line. We cannot hear you.
Hi.
Hello.
Hi.
How are you? Who is this?
Celestina.
Oh,
Cellophane, that's a beautiful
very
name.
nice. And what school are you calling from?
Glen Arden.
See, you were right. Lots of Glen Arden people. And how can we help you today?
I needed help with my homework.
Okay. You called the right people. What's your problem? Cellophina,
Hello?
are you there?
We keep losing people. I don't know why. This is very bizarre.
Hello?
Hello?
Oh, you're there. What's your problem?
My problem is 2/5
2/6,
2/5
5th. Okay.
plus 1/2.
Plus 1/2. Ooh. So, how much of this do you understand?
Well, this is kind of review because I already know it.
Oh. All right. Well, you talk me through. What do you know? What's the problem that we have here in combining these two fractions?
Well, if the denominator is unlike, then you have to find the least common denominator.
Excellent. Unlike denominators, we need like denominators. So, what is the common multiple that they both share?
10.
10. Very good. So we can make the denominator then 10. So we can change 2/5 to how many tenths?
4/10.
4/10. How do we do that? That is true, but how do we do that?
Well, since you multiplied 5 times 2 to get 10, you multiply 2 times 2 to get 4.
Right. So what we have here are two groups of 2/5, and they become 4/10. Okay? And then, how do you turn halves to tenths?
Well, to get 10 from 2, you multiply 2 times 5.
Okay.
You have to multiply 1 times 5.
Okay, and that gives us?
And you'll get 5.
Okay, and what's our answer?
9/10.
9/10. How come it's not 9/20?
Because when you're adding like denominators, you never add the denominator.
Excellente. Woo-wee. You are a rock star. So 9/10 is our answer. Excellent. I think you are well on your way to an excellent test score. Very good, very good. Would you like to try one of our challenges?
Yes.
You would.
Ooh, very
what
good.
would you like to try? Challenge 24 or the word of the day?
I want to try 24.
Ooh, okay. I have a strong feeling that you are going to get it right.
Which card? A, B, C, or D?
I want to do B.
B as in boy?
Okay.
But I already have the answer.
Great. 8851. Anytime you're ready.
Okay. What do we do?
8 minus 5 is 3. And 8 times 3 is 24. And 24 divided by 1 is 24.
Oh, what?
Go, Celestina, yeah.
Excellent job. Excellent. We need her name again.
She is a rock star for sure.
Rock star, math rock star today. Excellent job. Thank you so much, Celestina, for calling. I hope we've helped you today with your homework.
You did.
Awesome.
You helped me stay excited about math.
Awesome. Thank you for calling in, and keep watching us and tell all your friends about us. All right. Okay, I think we're moving on to the next one.
She was a rock star.
She was a rock star. She was great.
Next.
And who's there? Hello.
Next.
Hello?
Is this Paige? Paige.
Hello. Welcome to Count on Us. Fatima.
Oh, Fatima.
Is it Fatima? Hello.
Fatima.
Hello, Fatima.
Fatima.
Please let us help you today.
Are you there? Are you there?
Hello, 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 hello.
Hello?
Hello.
Fatima?
Hello? Hello?
Okay, turn down your TV. Turn your TV all the way down.
Okay.
And just talk on the phone. But watch us on TV.
Okay.
Hi, Fatima.
Hello.
How are you?
Huh?
How are you?
How old am I?
How are you?
Fine.
What grade are you in?
4th.
4th. Woohoo!
Okay, and you go to Glen Arden Woods?
Yes.
Excellent.
Glen
Very
Arden's
good.
in the house today.
Yeah, all over the place. And what can we help you with?
Huh?
What is your problem that you're working on today?
What is 5/10 plus 3/9.
Ooh, 5/10 plus 3/9.
5/10 plus 3/9. Woo-wee. All right. You understand that? How to work with unlike denominators?
Yes.
Okay, so what would be the common denominator between 10 and 9?
90?
Woo-wee, 90. Very good. Okay, so 5/10 equals how many 90s? How do we find that?
Multiply 10 times 9
Okay.
and 5 times 9.
Which is?
45.
Very good. Next.
Multiply 9 times 10, then multiply 3 times 10.
Which is?
30.
Okay. Next.
And it equals 75 90th.
Woo-wee! Very good. Are we done?
Yes.
No, we are not. No, we are not. Always, 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 always what?
Simplify?
Always simplify. So, can we simplify 75 and 90?
No.
If you look at those numbers, you can have what as a common factor to divide them by?
5.
There you go. Very good. So, those are big numbers there. So, do you know 75 divided by 5?
Is...
5 times 12 is 60, right?
Yeah.
So 60, 65, 70, 75. To go from 12, 3 more will take you to what?
14.
Not 14. One more.
15.
15. 15 times 5 is 75.
Cool.
What did I say? Divide by 5.
Is 15. Yep.
Now 90. Well, we did 75, 80, 85, 90, 15, 16, 17, 18. Ooh. Now look at this. Can we continue to simplify?
Huh?
Can we continue to simplify?
What?
Can we continue to simplify? That says 15 18ths. Can we keep going?
No.
No? Look carefully. What number has 15 and 18 in the times tables?
3.
3. Very good. So, 15 divided by 3?
5.
5. And 18 divided by 3?
6.
6. Now, guess what?
5, 6.
There you go. So, 5, 6 is your simplified answer. Whenever you have the numerator and the denominator one apart, you pretty much have found what you needed to find. But look, the reason why, do you know why it took us 2 steps to find the simplified answer?
Huh?
Do you know why it took us 2 steps to find this?
No.
Because what we failed to do was let's go through this. What's the factors of 75? 1 times 75. What about 2? Is 2 a factor of 75?
2 times 75 is 150.
No. The factors of 75. In other words, what 2 numbers equal 75? So can you multiply 2 by anything to get you 75? 75 is odd or even?
Okay.
Is 75 odd or even?
Odd.
Odd. So a number can only be divided by 2 if it's even. So it does not have 2 as a factor. But what about 3? 3 times what number gives you 75? Think
3.
money.
3 times...
What 3 coins will give you 75?
What?
what 3 coins will give you 75? What 3 coins will give you 75? Think money.
What?
Think about money. What 3 coins will give you 75 cents?
25.
25. There you go. 4 doesn't work. What about 5? We already said 5 times 15. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11, 12, 13, 14, none of them work. So the only factors for 75 is 1, 3, 5, 15, 25, and 75.
Okay.
Now the factors for 90 are 1 times 90.
90.
2 times, 45. What about 3? 3 times what?
3.
3 times what is 9?
3 times 3 is 9.
And 3 times what is 0?
What?
3 times what number is 0?
0.
So 3 times 30 is 90. What about 4? 4 doesn't work. What about 5?
4. 5, yes.
5 times what?
5 times...
Well, 5 times what gives you 100?
5 times 19.
5 times 20 will give you 100, right?
Yeah.
So 5 times 19 will give you 95. 5 times 18 will give you 90.
Okay.
See how that works?
Yes.
What about 6?
No.
If a number has 2 and 3 as a factor, then it also has 6. So 6 times what?
6 times...
6 times 15. I know that's a lot to think about.
I see it now. I see it.
Okay.
So do we have all the factors for 90?
What?
Do we have all the factors for 90?
Excuse me?
Do we have all of the factors for 90?
Yes.
No, we don't. What about 9? 9 times what?
10.
9 times 10. Now, do we have all the factors of 90?
No.
No. You have another one?
Yes.
What?
10.
Well, we have that, 9 times 10.
Huh?
We have that, 9 times 10.
Oh, okay.
11 doesn't work, 12 doesn't work, 13 doesn't work, 14 doesn't work, 15 works. So we have all the factors. Now, what we did was we divided by 5 because 5 is a factor for both. And then we divided by 3, but 3 is a factor of both. But we needed to find the greatest common factor. What's the greatest common factor between the two?
15.
15. So if we found this first and then divided, we wouldn't have needed 2 steps. And watch this. 75 divided by 5, 15, and then 15 divided by 3. Well, 5 times 3 is 15, and that would have been the greatest common factor. But that's okay. You can do it this way just as fine. Finding the greatest common factor is, I would say, most efficient. But with big numbers like this, sometimes it's just easy to do which ones you can do.
That's right. Break it down.
Break it down.
Break it down.
Okay.
Does that help you, Fatima?
Yes.
Very good, very good. Your name goes in our treasure box. Would you like to try a challenge?
Okay. Yes.
Which one would you like to try?
24.
24 challenge. Okay.
24 challenge.
Which card would you like?
B.
B. B as in boy. We've already had one solution. Let's see if you can find another. 8851. 8851. Okay, anytime you're ready.
Okay.
Oh no.
Okay.
Eight. Hold on. 8 minus 5 equals 3.
8 minus 5 equals 3. Okay.
Then 8 times 3 equals 24.
No, that's the same solution.
Oh, that's great, but it's the same solution that we had before. Same solution. Thanks for calling in, though, Fatima. You did a great job. All right. You learned a lot about factors, too. Greatest common factors today. And we put your name in the treasure chest. Hopefully, you'll be our winner at the end of the show. Thanks for calling. Now, before we go on, we've had a lot of Glen Arden people, and I think it's Miss Harding's class from Glen Arden.
Miss Harding?
Yeah. Shout out. Shout out to Miss Harding's class at Glen Arden. Thank you so much for calling in today. We have a few more minutes. We might be able to take one more caller. One more caller.
Are you out there?
Hello?
Are you out there? Are you out there?
Hello?
Timmy Land.
Hello, who is this?
Hello.
Hello? Who is this?
Paige.
Hi, Paige.
Paige,
Can you
turn your TV down and talk to us on the phone.
Okay.
Okay, great. And what grade are you in?
5th.
5th grade. Okay. And how can we help you today?
I have a problem with my homework I need help with.
Okay, what's the problem?
It's 2/8 plus 2/3.
2/8 plus 2/3. Well, it seems like everybody's doing the same thing today. So what do you know about unlike denominators? What do we have to do first?
List all the multiples.
We have to find common multiples. Do you know what the common multiple of these two are?
24.
Okay, so let's get it rolling here because we're running out of time for this part of the show. So 8 to 24, I'd have to multiply by 3. So what's 2 times 3?
6.
Good. Okay. 3 to 24, I'd have to multiply by 8. So 2 times 8 is?
It is 16.
Good. Okay. Now all we have to do is add these. 6 plus 16. 22 24ths. You don't change the denominator, just add the numerator. Are we finished?
No.
No. We have to simplify. So what can we divide by to simplify?
Divide by 2.
Very good. So 22 divided by 2 is 11. 24 divided by 2 is 12. They're consecutive numbers, so I know I cannot simplify anymore. And there is your final answer, 11/12. Sorry. Woo. I'm thinking about the 22. We are going to put your name into the treasure chest, and we have to get moving because we have to pull our winner. It's almost the end of the show. If you are on the line, please stay on the line.
Hold on.
Don't hang up. The next show will be happy to help you, but we have to pull our winner for this show. Go ahead, Mr. G. Who's the winner going to be? Who is it?
Me!
No, not you.
I can't be the winner?
No. No. Who is it?
Paige from Hollywood!
It's Paige! Excellent job. Excellent job. Thank you so much for calling. Please stay on the line. Do not hang up. The intermediate show is coming up next, and they'll be happy to help you. But remember, until then, from the elementary, Mr. G.
Count on us.
Bye, guys. Have a great afternoon.
Hello, my name is Mrs. Sun, and I'm here with today's mini lesson on area. Very often people learn about perimeter and area at the same time, so I want to talk to you about what area is and the difference between the two. Our objective today is to apply measurement concepts in order to determine area. Area is the number of square units inside a shape. So we are looking at the inside of a shape. So very often you're going to look for keywords in word problems. Sometimes people are talking about finding carpet for a room or tile for or a floor. Look for those keywords where the word problem is talking about covering the inside of a shape, because often they won't say find the area. They will say how much carpet is needed, or how much tile is needed, or how much paper to cover. That would be another keyword, a bulletin board. So look for those keywords, and we're going to talk about how to find area in a moment. There are a few different ways. Let's take a look at word problem number 1. Melanie wants new carpeting. There we go. There's that keyword for her family room. Her family room is 8 feet by 4 feet. How much carpeting does she need to cover the room? Anytime there's a word problem and you don't see the shape, go ahead and draw that shape. So I'm going to draw a rectangle here. It's not going to be the prettiest rectangle, but it's going to work. And we're going to label that. We know it is 8 feet by 4 feet. Now, in order to find the square units inside, we often multiply to find the area, and that will work, but I want to explain why that works. When we are multiplying to find the area, 8 times 4, what we're doing is 8 groups of 4. So what we're really doing is we're really building an array inside of this shape. So we would break this up into 8 groups. Okay, that's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They're not equal, but pretend they are. And then here we would have 4 groups. So what we are doing when we are multiplying is we are building rows and columns of equal groups to build an array for 8 times 4. So if we counted that out, we would know that that would equal 32 square units. Since we know it's feet, that's 32 square feet. Anytime we're talking about area, we want to talk about the square units because we are building those square units inside of a shape when we multiply. So to find the area of a rectangle or a square, I want you to multiply, but the reason is you are building that array inside. If you are finding perimeter, I want to talk real quickly about the difference. Perimeter would be the distance around. So it would be 8 plus 4 plus another 8 over here plus another 4 over there. But that's another mini lesson for another day. Let's take a look at one other problem. I really like this problem. This is from mdk12.org. Nathan divided his rectangular garden into 8 sections that are the same size and shape. What is the area of the whole shape? So this side right here says 4 feet, and this says 7 feet. So there are a few different things we could do. If we want to multiply length times width, we could find the length and the width of the whole thing. If this section is 4 feet, this section is 4 feet, so this whole thing would be 8 feet. If this is 7, and we know that this is a rectangle, then this is 7, and this is 7. So this whole thing would be 14 feet. So we found the whole length and the whole width by using what we know about these rectangles right here. So we could multiply the length times the width, 14 times 8. 8 times 4 is 32. 8 times 1 is 8. Plus 3 more is 11. So it would be 112, remember, square feet. Okay? Now we could also find the area of this rectangle right here by doing this rectangle right here would be 4 times 7, because that's length times width, which is 28, and then 4 of these exact rectangles. So 28 times 4 would be 8, and 3 more would get you the same answer, okay, square feet. But I like to find the length and the width of the whole rectangle. Otherwise, be careful, because 7 times 4, 28, was the area of this whole rectangle, and that whole rectangle happens 4 times. So be very careful of word problems, but remember, for rectangles and square, length times width. If you're not sure, you can always remember ma and pa, multiply area, perimeter, add. That will help you remember the difference. So, my name is Mrs. Sun. That was today's mini lesson on area, and I hope you have a wonderful day.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math? Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Welcome back to the second half of our show, Count on Us, the secondary edition. My name is Mr. Pugh.
I'm Ted Herman. I'm sitting next to a very shy guy, but one day he'll come out with his personality on the show. Call us up at 301-772-0080, and you can get the answer to all your questions out there in TV land on math.
I want to say Happy New Year to everyone for our first second show back. My first day back since the new year.
Oh.
Happy New Year. Good to see everybody in the year 2014. As you all know, we have a few challenges for the show this evening, as we always do. Our first one is a challenge 24. You all know how this goes. We have letters A, B, C, D. Also, so you know you can use you must use each digit only one time. You can use any operation, addition, subtraction, multiplication, or division, and you must get a final answer or solution of 24.
And this is a 9 right there, right, Mr.
Yes.
Pugh?
The ones with the upside down 6 or colored in there 9.
Mm-hmm.
No, digit is a 9.
Right.
That's a 6. That's a 9. We always ask if you please have the problem already worked out before you call the show, because you know sometimes we have kids waiting to answer questions, so we want to keep them waiting while you work out the problem. So please have it worked out before you call the show, and you must ask a question, homework question, before you try one of our challenges. We have a second challenge for you today, which is called the problem of the day. Kind of easy and simple, something to get you thinking about. You know, it says write in a number expression, give its value. Antonio had $134 in his savings account. He put in $67 more. How much was Antonio's account then? We will be back and have a different problem of the day after this one. I think this one might be a little easy.
They're going to be solving that easy, but let me give you a couple of hints on this. The reason why they call it problem of the day is a problem of the day. This is the day we're going to do the problem. So the problem is right there, but it's today.
You cannot touch this man's mind. It's completely over the dust. You must continue to watch this show because you can always count on
us.
Oh, you like that rap, didn't you? Our producer's back there shaking in his boots.
Hey,
all right.
Always turn your TV sets way down so we can talk to you on the phone and you can hear our voices and we can hear your lovely voices too.
Well, I think we have some callers. So before we go to our first caller, I want to say his sweater is telling us Merry Christmas, Happy New Year. Thank you so much. All right, let's go to our first caller. Caller, are you there?
Hello.
No, you're not there?
Hello.
Hello?
Hello.
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 Hello, hello, hello. How are you today?
Hi, Kyla. How you doing?
Hello.
Hi, Kyla.
Hello. We're already past the hello. Let's
how you
move
doing,
on.
Kyla?
Huh?
Hi, how can I help you, Kyla?
I'm good.
What school do you attend?
Huh?
What school do you go to?
Well, I have this, I need to answer this question for my math homework. And the question is, if 1 gallon of paint covers 100 square feet, about how many gallons of paint will Tawny need altogether?
1 gallon covers 100 square feet?
Mm-hmm.
How many gallons does she have?
Huh?
How many gallons does she have?
Well, I don't know because I'm really, we're learning this at school, but I'm really having trouble in school.
Okay, I understand. So I'm asking you this question. You gave me a scale. It's called a scale, okay? You're telling me that if she has one gallon of pink paint, it covers 100 square feet. So either the question gave you how many gallons she have or how many feet she covered. So which one is it the two? Did the question ask you or tell you how many gallons she has or how many square feet did she cover?
100. It said 100 square feet, but I'm not sure if it means perimeter or area, because this is a perimeter and area.
Square feet is area, because area is measured in square units, okay?
Okay.
So it's area. However,
all right.
I need to know another question. Can you do me a favor? Are your parents around?
Huh?
Is your mommy or daddy around?
Nope.
Oh, you by yourself? So let's do this. I want you to look back and reread the question again. Give us a call back because you're missing something from the question. Okay?
Okay.
All right. Bye, bye, Kyla.
Bye, bye.
I love great students who do works hard and want to call in the show for extra help and assistance. Unlike our producers pushing the wrong buttons, but it's okay. We love our producers. So you want to help her out?
But I can't really put her name on the box yet because she hasn't really given us a question.
So, Kylan, we're going to keep your name right on the side. When you call us back, we put it in our treasure chest. Let's go to our next caller.
And all I'm going to say is to our directors back there, if you're going to give me a close-up, make sure it's up close and personal, okay? Because I want to be warned about these things so I look half decent. Thank you so much. Geraldine. Is that Geraldine from Glenarden Woods? Hello?
Yes, I'm here.
Hi, how you doing?
How you doing, Geraldine?
I'm doing good.
And what grade are you in? I bet you're in 5th grade.
What?
What grade are you in, Geraldine?
What my question is?
What grade are you in?
Oh, I'm in 4th.
Okay.
I missed it by 1 year. Okay, well, what's your problem today, Geraldine? I'd love to help you out.
My problem is, it's, I figured out where it was. Oh, wait, here it is. It's 7/8 times 2/3.
Well, 7/8 times 2/3 means you're working with fractions, right, Geraldine?
Yep.
And you're multiplying the fractions?
Yep.
All righty. Well, in your class, are you cross-canceling, or you want to just multiply straight across?
Multiply straight across.
Well, hello to you, too. Okay? Hello to you, too. Let's just keep going because I'm on the air doing our TV show right now, and I can't wait to help Geraldine some more. So we're going to go ahead and multiply 7 times 2 is what? How much is that, Geraldine?
14.
Excellent multiplication. And what's 8 times 3?
And 8 times 3 equals 24.
And I can tell you're learning your facts in 4th grade. I'm proud of you for that.
Good job, Geraldine.
But, however, that answer is not in simplest form. Do you know how to get it down to simplest form, 14/24?
14, you can divide both by 2.
You are terrific,
You're
Geraldine.
awesome, Geraldine.
I'm
Awesome.
really proud of you at Glenarden
Great
Woods.
job. Great
I bet
job.
you're making your teachers proud every day.
Yes,
So
you
what is 14 divided by 2?
7,
Yep. And 24 divided by 2?
12.
Excellent. Is that in simplest form?
Yes.
Yes, it is. We can't divide any other number inside 7 and 12 at the same time by the same number. So, how do you say the answer again? What's the answer? 7 over 12. How do you say it in fraction? How do you say 7 over 12 in fraction form?
7/12.
Outstanding. You know what, Geraldine? You just got your name as the first contestant into our treasure chest, and you want to try a challenge while we're on the air?
Yes, I want to try a 24.
The 24 challenge. Mr. Pugh is so good at this, I'm going to turn the show over to him.
Oh, thank you so much. so Geraldine, you want A, C, B, or D? A, B, C, D.
Like
D, C, B, A. A, D, C, B.
He knows his math, but he's alphabet challenged.
Which one do you like to try, Geraldine?
I'll try.
Let's do this, Geraldine. Why don't you look at the show, pick which one right now, and write down your 4 numbers.
C.
Which one? C?
Okay,
C?
yes.
2, 6, 7, 8. 2, 6, 7, 8. 2, 6, 7, 8. So tell me what to do.
I got the numbers, but can I call back?
All right, Jordan, we're going to have you call the show back, okay? We have people waiting. I'm going to show it again, write it down, and you give us a call back when you have a problem worked out, okay? Thank you, Geraldine.
Okay.
Here are the numbers again, Geraldine, while you're out there. Here's A, C, B, D. Please write the problems down you all want to work on and have it worked out before you call the show. Once again, A, C, B, D, and that is a 9. That is a 9. That is a 6. Please have it worked out before you call the show. So all you online waiting, if you want to try Challenge 24, write down A, B, C, or D, and have it worked out before you call the show. All right, let's go to the next caller. Hi, Ibrahim?
Ibrahim.
Yes.
Do me a favor. Turn your TV all the way down. All the way down.
Okay. Yeah, I just did.
You just did? I just like doing this dance, that's all.
Okay.
Okay. How can I help you?
Huh?
How can I help you?
I would like to make a multiplication question.
Okay. You would like to make a multiplication question or give me a multiplication question?
132 times 36.
132 times 136?
No, 132 times 132 times 36.
Okay, times 36. Okay, tell me what I'm supposed to do first, Abraham.
First, you will want to multiply 2 times 6.
2 times 6 or 6 times 2? Okay. What's 2 times 6?
That's 12.
I drop my 2, carry my 1. I regroup or carry over my 1. I might use all my vocabulary. That's all.
3 times 3 equals 9, but if you add the 1 to the 3, you'll actually get 4 times 3.
No. I'm asking you a question. You told me 6 times 3 equals 9?
Huh?
You told me 6 times 3 equals 9?
No, 12. 2 times 6 equals 12.
I dropped my 2 and I carry my 1. What do I do next?
Huh?
What do I do next after I do that?
Sorry, my phone is breaking up.
That's okay. What do I do next?
Breaking up is hard to do.
Okay, so say that again.
So what do I do next?
You multiply 6 times 3.
And what's 6 times 3?
6 times 3 is 18.
18. You said 9 before. And what's 18 plus 1?
19, actually.
19. So you saw your mistake. You see your mistake now? I want you to correct your own mistake, because when you understand your own mistake, you can better solve these problems yourself. So because at first you said 6 times 3 is 9, and then you said 3 plus 1 is 4. So he did 2 different operations, and they both weren't correct, but I like the way you fixed it and rethought the problem. Okay?
Okay.
Let's continue now. So what do I do next?
Okay. You multiply 6 times 1.
Which is?
6.
What I do with the one I carried over?
6 times 2
No.
equal...
Where's 2 coming from? Where's the 2 coming from? Say, I already found your misconception, Ibrahim. I found it in 20 seconds because Mr. Herman taught me well. So listen to me. You told me 6 times 1 is 6.
6 times 1
is 6, right? And then you said 6 times 2. Where did 2 come from?
2 times 1 equals 12.
You're not listening to me, Ibrahim. You're not listening. Let me lead you follow right now, okay?
Okay.
Listen to me. You said 6 times 1 is 6. You are 100% correct. And then you said 6 times 2. Where did the 2 come from?
If you add 1 plus 1, you
that
get
one
2.
is, now listen to me. That 1 is already gone because you multiplied it by what?
6.
Right. So what do I do with that extra 1? I add it to my what? Factor of 6. Don't I?
Okay.
So what's 6 plus 1?
6 plus 1 equals 7.
7. That's your misconception. When you regroup or carry over these numbers, Ibrahim, you don't add them to the top number. You add it to the product of the multiplying number. The product is the key word. You add it to the product. So let's do this. Now I'm going to go to the 3. Because the 3 is in the tens column, I'm going to put a 0 as a placeholder in my ones column. Because it's really telling me 30 times 2. But what is 3 times 2, Ibrahim?
2 times 2 equals 4.
I say 3 times 2, Ibrahim. Listen to me.
3 times 2 equals 6.
A great job. Great job. And what's 3 times 3?
9.
9. And what's 3 times 1? And what's 3 times 1?
3.
Excellent job. Now, Abraham, what do I do in this next part? What am I supposed to do? What operation?
You would add 0 plus 2.
2 which is 2.
2. 6 plus 9. You will have to regroup that 15.
Oh, I like that regroup. I like that. Yes, yes.
And then you put the 1 where the 7 is.
Yes.
7 plus 9 is 16.
Yes.
But if you add the 1 to the 7, it's actually 16.
Say it again.
17.
Oh, great job. I love the way you think the problem. Good job.
He's catching fire now. He's really on a roll.
And what's 1 plus 3?
1 plus 3 equals 4.
Now, what's my final answer solution?
132 times.
Are you watching the TV screen?
Huh?
Are you looking at the TV screen?
Huh?
Are you looking at the TV show?
Yes.
All right, look at the TV show. What's my final solution?
132.
Are you looking at the TV screen? Solution means answer. What's my final answer?
It's 4,752.
Good job. Now I'm gonna say, hey, Ibrahim, you're an excellent student at Glennon Woods because they have excellent students. I love your question today. I'm gonna say 2 things to you. Be careful with the regrouping and the carrying over numbers, okay? Because that's where that's where you make your common mistake. The second thing, I love the way you read this number, but you say and it's not and. And means decimal point, so it'll be 4,752. And I like that. But I'm gonna give you something because what grade are you in? 4th grade or 5th grade?
Okay.
What grade are you in? What grade are you in? Well, I'm gonna give you a hint. When you get in middle school, the word solution means answer, okay?
Okay.
And your name is going in our treasure chest.
Absolutely.
Continue to watch the show at the end of the show.
Yeah.
You might be our winner.
Okay.
And also, I'm a flash. I'm China 24. And you want to try China 24? Just give us a call back. Okay, Ibrahim?
Okay.
Great question. I love our students out here. Great students.
I'm glad you're happy.
I'm so happy. I'm excited. They want to learn mathematics.
It's a happy new year.
Is it happy? Is it really?
Happy.
Christmas sweater.
Golf sweater. There's no holiday here. Ain't no holiday. It's straight up. It's sports activated. What are you wearing?
My middle school sweatshirt. Ernest Justice in the building.
The one you washed last year once. Okay. Well, it stands on its own merit. Let's go to the next question. And next caller is on the air with Rose. Is that Rose?
Yeah.
You called on Monday, too, didn't you, Rose?
Uh-huh.
Good to hear from you again. How's Catherine T. Reed going?
Good.
And what grade are you in, Rose?
My question is
Sure.
2 1/2. How do you turn that into an improper fraction?
Say that one more time. 2 1/2?
Mm-hmm.
And make it into a what?
An improper fraction.
An improper fraction?
Mm-hmm.
Right. Well, that's a fraction that has no manners, okay? It's acting very improperly. So what we're going to do is take this mixed fraction and we're going to change it to an improper fraction by taking the denominator, this 2 down here, and multiplying it by that whole number 2. What is the 2 times the 2?
4.
Yep. Then after you've done that process, you add the 1 that's on top in the numerator. So what's the 4 plus 1 make?
5.
Excellent. Does the denominator stay the same or change?
Stay the same.
I love it. So now we have an improper fraction. Can I show you something else real fast? Since we already got that answer straightened up, 5/2 is what 2 1/2 is equal to. Which one's the mixed fraction there, Rose?
2 1/2.
And which one's the improper?
5 2.
Well, we're going to say 5/2. Can you say 5/2?
5/2.
Excellent. And I think they call it improper because look what's wrong. What's wrong with that numerator compared to the denominator?
The numerator is higher than the the numerator is higher than the denominator.
I love it. I love it. So I'm going to draw these circles here. All right.
Mhm.
And voila. I'm going to make them into halves. Okay. Look at that. So beautiful. Oh. And then I shade this. I make that shaded here and I'm shaded there. And how many whole circles have I shaded in so far? Rose, how many circles have I shaded in all together?
2.
Yep. And then I have a little bit more to shade. So now I have what? 2
and 1/2.
I love it. But now if I count the halves by themselves, let's count them together. 1/2, 2, 3. Oh, I like your marker. Much better than mine. 1. Let's do that again, Rose. 1. Mr. Pugh is doing a great job with that. 2, 3.
3. 4. 1/2.
Oh, what happened to the next number after 4? Let's try it again. 1.
2. Oh!
No, not O.
3.
Nice try. Start over again.
3, 4.
1, 2, 3, 4.
4, 5.
Yes. 5 whats?
5/2.
Oh, man. You get a ringy-dingy because Rose is the best. Do you want to try, after you got your name in the drawing, do you want to try a challenge problem, Rose?
I would like to do the challenge of the day.
Oh, Rose is one hard worker. She knows her stuff. Write a number expression, give its value. Antonio had $134 in his savings account. He put in $67 more. How much was in Antonio's account then?
201.
How'd you get that?
Because
right.
I'm really good at adding.
And what did you add together?
I did 134 plus 67, and then that's when I did 7 plus 4. That was 11. Then I carried the 1. The 6 plus 3 is 9. Plus the 1 is 10. So I put the 0 down, carried the 1, and 1 plus 1 is 2.
I love you. You're terrific, Rose. You get your name in the drawing twice now. Let's hear it for Rose. Give it up for Rose. You know what, Rose? You're growing and you're really blossoming out into a lovely flower. Nice job from Catherine T. Reed, a first-time caller.
Now, Kyla, Geraldine, Harris, I want you to stay on the line. We have to take a short commercial break. After the commercial break, we will give it to you after our short commercial break. I'm so sorry right now. I can't even talk. After that wonderful math lesson.
You're
but
so
we'll
excited.
see you after the break.
You sound so excited.
Hello, my name is Shayla Tucker from Stephen Decatur Middle School from 6th grade. I'm here with your email corner for today. Here's our problem. Judy has 8 candy bars. She wants to give 1/3 of a candy bar to everyone in her class. Does she have enough for all 24 students? We already have our diagram divided into 3 pieces, so now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 pieces. And now for our numerical expression, we have the total of candy bars, which is 8, divided by the parts that are shared, which is 1/3. So we make our fraction, which is 8 divided by 1/3. Now we have to find the reciprocal, and we have to change 8 to 8 over 1 because we have to make this a fraction, times 3 over 1 because that's our reciprocal, which equals 8 times 3, which is 24, and 1 times 1 is 1. So our solution is she has enough for all 24 students to have a piece. My name is Shayla from Stephen Decatur Middle School with our email corner for today. See you next time.
Can you tell?
Can you tell?
Does it look like I'm fighting a disease?
Fighting.
Fighting.
Fighting for my life.
Like my life expectancy is shorter than yours?
There's no outward sign.
But we're battling every day.
Every day.
Every day.
Worrying, testing,
Treating.
Fighting. Fighting. Diabetes.
Diabetes has been called a silent epidemic. It's time to call it out for what it is. This is Brett Michaels. Join us. Choose to share, act, learn, and give. Help us stop diabetes.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly.
I wanted to be a cowboy.
Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Welcome back to the second. Welcome back to the second half of our secondary edition of Count on Us. Once again, I'm Mr. Pugh.
I'm Ted Herman. If we didn't tell you before, you can catch us on the computer on the www.worldwideweb.pgcps.org and go right on down and find podcasts, and you'll find us. I even hear we're on YouTube, Mr. Pugh. If you look up on YouTube and type in Count on Us TV show, you will be able to find some of our wonderful episodes from the past times.
So you want to go to the phone calls, or you want to talk about Devin Williams from Roosevelt?
No, let's go to the phone calls.
Let's go to the phone calls. Okay.
I want to
Let's go to the next now. Let's go to the next
keep
call.
my job alive.
Caller, are you there? Caller, are you there?
Is that Kyla?
Kyla? Hi, Kyla.
Hi.
You called back for a challenge?
Yep.
Yep. He's so excited. Which one did you select, little mushkin? Which one you select, A, B, C, or D?
I can't understand because my phone is breaking up.
Okay. Which? Oh, my microphone breaking up. Which one did you select?
I didn't select any because I didn't get to finish my question, the one I was asking you.
Oh, what's your question?
You never finished your question.
Oh, that's right.
It's about the gallons of paint.
The 1 gallon of paint.
100 feet of square feet or something.
Okay, Kylie, what's the question?
If the question was if 1 gallon of paint covers 100 square feet, about how many gallons of paint will Tony need altogether?
For what?
Right. How much job you doing?
How much work? How much he trying to cover?
Huh?
How much feet? How much feet he trying to cover? How much square feet he trying to cover?
Well, it said 100 square feet, but it said how many will Tony need altogether.
Okay, so look. So it's what? So look. Okay. Kyla, I'm trying to make a inference. Okay.
Okay.
Inference means an educational guess based off the information you gave me. Okay.
Okay.
I used to be an English teacher too. I know I don't sound like it, but I used to about 10 years ago.
He's like a dictionary.
So Kyla, I believe this question is asking you to determine if this is area or if this is perimeter, correct?
Correct.
So remember, area is measured in square units, okay? And because it says square feet,
yes.
So we automatically know that this problem is dealing with what?
Okay.
Area, correct? Because I'm gonna give you another example. Perimeter does not deal with square feet or square units, okay?
Okay.
Like the next thing you're gonna learn is something called volume. And volume is a big word for you right here, cubic units. Because cubic units means 3, okay?
Okay.
So I'm assuming the answer to your question is it perimeter or is it area? And because we now know that area is measured in square units, so the answer must be area, okay?
Okay.
I'm giving you all my hand gestures.
Can we go back to an overhead visual for 1 second? I just want to lay this out a little bit for Miss Kyla, who's really worked hard on this problem with Mr. Pugh. You know, Kyla, if you're going to put paint on the wall, aren't you going to spread it on like a paintbrush or a roller or something like that? Well, good job. Let's try to pretend this is a wall. So I'm just going to build some more wall here.
Sorry, my phone is breaking up. I can't hear.
He said pretend that this is a wall that he's painting right here, okay?
Okay.
All right, so I'm going to talk while I'm going translate for you.
All right.
So let me ask you just one question, Kyla. If you're putting the paint on this wall here, this green wall, are you going to roll it on top of the wall, or are you going to just trace around the outside of the wall?
You're gonna paint on that.
On that whole surface? Oh, that means area. Area means you cover everything on the shape.
Okay.
Perimeter means you go around the outside. Okay?
Okay.
That's all I wanted to say.
Thank you, Kyla.
You're welcome.
Did you have another question or you want to try a challenge?
Nope.
Oh, I like that. Well, Kyla, we're going to put your name in the treasure chest.
Yeah,
Continue to watch the show, and you might win our grand prize at the end of the show.
Oh, yeah, it's in now.
You might win the sweater.
She got...
Bye, Kyla.
I don't know why he's sweating me like that. Okay, let's keep going here. Next caller is my caller, I guess. On the air with blank person. Who's that?
Hello?
Hello, who are you?
David.
David. How you been, David?
Good.
How's the family? Everybody doing good?
Yeah.
Did you have a nice vacation?
Yeah.
What grade are you in?
6th grade.
6th grade. What school is that?
Kenmore Middle School.
Oh, that's right across the street from our studios. Very good. Kenmore Middle. And what kind of 6th grade question do you have today for us, David?
Dr. Trees.
Who?
Dr. Trees.
Dr. G's.
Factor trees.
Factor trees. Thank goodness. I don't even know Dr. Drees that well. But factor trees, what kind of number do you have for our first factor tree?
Huh?
Do you have a number for us?
Do I have a what?
A number for the factor tree.
Yeah.
Well, do you mind sharing it with us?
92.
92. And what do you want to do with that 92, David? Do you want to show a factor tree with 92?
Huh?
Do you want to show a factor tree with the 92?
2 and 46.
Whoa! How do you know 2 is going to work? That's what I'm curious about. How did you know, David, that 2 would be okay to multiply into 92?
Hello?
Good, because 92 is an even number. Ends in 0, 2, 4, 6, or 8. Therefore, 2 would go into it. And would you say 2 times what makes 92? 40?
46.
Excellent. Now, I'm going to circle the 2 because that's prime. You know what prime means?
Yes.
What does it mean, David?
That no other number except for 1 in itself can go in it.
Man, you know your terms very well. Nice job. But 46 can be broken up more by 2 more factors.
2 and 23.
There he goes again with a 2. He's right. And I'm going to circle that 2 and the 23. Why am I circling 23, David?
Because nothing else can go in it except for 1.
It's prime. Very good. You know your definition is very good. So here's what your teachers might write on your answers tomorrow. Or, since you're in the 6th grade, they might have written a little tiny 2 up top. Multiplication, 23. Do you know what a little tiny 2 up top means?
Yeah.
What does it mean?
2 to the 2nd power.
I love it. 2 to the 2nd power. He gets a ring for that, man. That is terrific. And your name's going right into the treasure chest, David. So very proud of you at Kenmore Middle. And you want to try a challenge, either the 24 challenge or the problem of the day. Another problem.
The 24 challenge.
Fantastic. And we got to find a new problem of the day while Mr. Pugh's getting your 24 challenge all straightened up.
So you want to tag team it off, or you want to do it?
I'll work with you if you'd like to. Sure.
Okay.
I want to do B.
B as in Bubba?
Yeah.
Okay. 7154. 7154. All right, David. Give us your best start on 7154 to make 24 happen.
7 times 4 equals 28.
Oh, yeah. 7 times 4 is 28.
28 minus 5 equals 23.
I think he's on the right track.
And 23 plus 1 equals 24.
Oh my goodness. Oh, you got a smiley face from Mr. Pugh.
They
David.
didn't show it, though. They didn't show it.
Oh, that's a shame. He didn't get his props. There you go.
There you go.
At least they didn't give me a close-up while you're doing that. But here you go. Your name goes into the treasure chest again. Twice now, David. What a great caller. He knows prime numbers. He knows factors. He knows everything.
He knows vocabulary very well, too.
I was really impressed.
Yes.
Next caller goes to Mr. Pugh.
Next caller, are you there? Hello?
Hello?
Hello? Is this Geraldine?
Yep, it's Geraldine.
Hi, Geraldine from Glenarden. So you want to try a challenge?
I already got the challenge and I'm done with it.
Okay, what challenge did you do?
I did card C.
Right here? 2, 7,
Yeah.
2, 6, 7, 8. Okay, here we go. 2, 6, 7, 8. Let's go.
Yes.
2, 6, 7, 8. Tell me what to do, Miss Geraldine.
Okay. I did 7 minus 6 equals 1.
Go ahead. I think my producer said you have it, but go ahead. Go ahead.
Yeah. And 1 plus 2 equals 3.
Okay.
And 8 times 3 equals 24.
Oh my gosh. 2 in a row callers got it? I hope they caught the happy face that time.
I think they got a little quick glimpse of it.
I hope they're not dissing your happy face.
Glimpse of it.
That's beautiful. Geraldine, I got to give you a rap for that. I got to give you a rap. You just called Mr. Pugh. That's because you are you. That's
and
all
you're
I got.
awesome in everything that you do because you're a mathematician. From here to the sky turns blue.
Oh my goodness. I'm going to the zoo. Yeah.
You work with Mr. Pugh and Mr. Herman for the next 5 hours. Believe me, we will be here to answer all your what? Questions.
You guys are funny.
Thank you, Geraldine. Have a great day.
Gosh, bless you. Nice job. She knew her stuff. Oh, Mr. Pugh, you got a chance to show your stuff.
I try my best. You're the perfect partner.
I love it. I love being with you. And next caller is Harris, I think. How do you say your name?
Hello?
Hello.
Harris.
How you doing, hello?
Harris.
Can you turn the TV all the way down? Here goes Mr. Pugh. He got the moves. Bring that TV volume down. Nice remote control there. Harris at Glen Arden. Glen Arden's really calling in today. What's your question, Harris?
My question is, by looking at its height.
You got to turn that volume down your TV. Hold it. Time out. Turn your volume down on the TV because you're getting all this feedback and we can't understand a thing you're saying. I just heard my voice.
Okay.
Thank you. Okay, go ahead.
My question is, explain how you would decide which unit is best for measuring your math book.
For measuring your math book. Can I ask you a quick question? I heard my voice again. Anyway,
Sure.
Is it customary units or is it metric? Do you have a volume control on that TV set? Can you turn it down low? Please, Harris. What we have here is a failure to communicate.
There we go.
That's good. Okay, are you using millimeters and centimeters, or are you using inches and yards and feet?
Inches, yard, and feet.
So that's called customary units. Can you say that word?
Yes.
What is it? Customary. Customary units. Can you say that?
Yes.
Good. Well, so you want to measure your math book, do you? Well, let's get a sample math book. Mr. Pugh, I think I have one right here. This would be a sample math book. We'll show that for a visual. Thank you. Now, we're using inches, feet.
Yeah, that's what you want to determine which customary units is best to use to measure math book.
Right, that I understood, but I'm trying to just emphasize those words.
Oh, I'm sorry, sir.
So let's, you know what? An inch, I believe, Mr. Pugh, you know more than I do about this stuff.
No, I don't.
I think an inch is like from one part of your knuckle to the other knuckle.
Yeah.
That's about an inch right there.
I do
so
know
we
that.
could measure. Thank you.
I'm sorry.
I'm sorry. I got a little crabby this now, I think. But that'd be an inch. Or you could use a foot, which is like the size of my shoe. I have a 12-inch shoe, so let's go ahead and measure with the foot. A ruler's better, but here's the shoe. So there it is. It may not, I don't know. You have to figure it out yourself, Harris. And a yard, that's a yardstick. That's like from one tip of my finger, let's go this way, to my nose. All the way from my tip of my finger up to my nose. That should be a yard. But I have short arms, so it doesn't really qualify. Mr. Pugh, look at that man. He is a demonstration for a yardstick. I love it. Yeah, he looks good on TV. So, Harris, we're back to you. Do you think you'd use an inch to measure, inches to use to measure the math book, or a shoe, foot type thing with a ruler, or a yardstick?
I think feet.
Feet. Well, I think you just got defeated. Because I'll tell you why. I'll tell you why I got defeated on that. Because my shoe, which is actually representing 1 foot, 12 inches. Look how, let me go sideways on the shoe, on this book. Watch. There you go. See my shoe? There's the tip of my toe on the edge of the book. And now look at all leftover heel. That is not good. I have too much leftover. I want to be more accurate. So let's go change that. We can't use feet. We can use what? Either inches or yardstick. Harris?
Inches.
Yes. Now we're talking. Now we're talking math. So Harris gets his name into our drawing for being so sharp. Do you want to try a challenge? We have a new challenge problem of the day, by the way. There it is.
Yes.
Okay, you want to try 24 challenge or the problem of the day? And we'll show that to you right now.
Number challenge.
Number challenge. Number 24 challenge, I think that's what he's talking about. Okay, do you have a circle you want to pick?
D.
D?
Yes.
D, that's one of the hardest ones there. 5882. Mr. Pugh, you want to take over on this because you're so good with 24 challenge?
All right, Harris, so let me know what to do. Take your time. Remember, you have to use all 4 digits. You can use any operation you like. You can use addition, you can use subtraction, multiplication, or division. I'm going to do this for this. Or division. All right? But your final answer / solution must be 24. So tell me what to do first.
Times 8 and 2.
Times 8 times 2.
Yes.
I like that. You're on the right track so far.
Is he? Okay, I'll
What's
get
8
his name
times 2?
started.
16.
Okay, I like that. I'm going to cross out 1 8. I'm going to cross out 1 2. Now, this next thing you tell me what to do is the most pivotal thing. What's next? What I do next? Think about it. What I do next? Are you stuck? Harris?
Add 16 and 8.
Oh, Harris. No. 16 plus 8 is 24. But you still have the 5.
Oh, wow.
So, Harris, I'm going to show you how to solve this problem right now, okay?
Would you? I'm stumped.
So, Harris, I'm going to say thank you for calling the show. Continue to watch the next 2 or 3 minutes. We'll be putting our winner out the hat in a few minutes. But before we do that, I'm going to solve this problem for you, okay? So the next time you call on Monday, you know how to do a time of 24. So thanks for calling the show. See you later, Harris. All right. So, folks who are watching the TV land out there, I'm going to do this problem right here. I like this problem right here. It's a good challenge. I'm going to use 2 multiplication problems to solve this.
That looks hard to me.
So I'm going to say 8 times 5.
Okay,
That's 40.
40, yeah.
Counts to 1 8, 1 5. I'm going to use the same numbers, 2 numbers Harris gave me.
I got you.
8 times 2,
I got you.
which is 16.
Uh-huh.
Counts. Did I use all 4 digits?
Absolutely true.
So I'm going to say it's first 40 minus 16.
24. Oh, I'm putting your name in the treasure chest, Mr.
Can
Pugh.
I win?
No.
Can I win?
No, but
I can't win?
it'd be nice to have your name in there anyway.
I want to go home. Toto, go home. Devin, go home. Okay. Okay. Devin Williams from Roosevelt. Go home. All right. So you ready to pick our winner? Or
I don't think so, because I got to tell you what we did today in class.
Oh, yes, sir.
I mean, do we have more time to talk about
we
this?
we have a little free time, 2 or 3 minutes, and we have no callers on the show right now.
If you don't mind, I would
like to thank all the callers for calling in today. Thank you for a wonderful show today. We want to learn what Mr. Herman did today in school. So more math.
Okay. I'm going to write this word out so you'll have a clue what we're studying right now. Our new unit started yesterday.
No, it didn't.
It really did.
No, it didn't.
Okay, it didn't.
Okay.
It started Monday.
All right.
Geometry.
Geometry.
You know what?
Geometry.
Geometry.
Geometry. Okay.
That's what the acorn said to the tree when it grew up.
Geometry.
Geometry.
This is mad fun. You don't
I'm
get it.
telling you. Now, what kind of lines did I just make, Mr. Pugh?
Parallel.
Oh, yeah, because they're never going to do what?
They're never going to intersect or touch.
Oh, my gosh, you're so good. And now you tell me what kind of lines we learned about today that make this happen, and you have a little box there.
I'm so glad you put that box there, because I was going to say intersecting lines, but that box made is perpendicular.
Oh, you know, I wish you were in my class. You'd be getting A's.
No, you wouldn't. It took me 6 years to say the word perpendicular. I could say it for the first 6 years I was teaching.
Okay. And what does that box stand for, Mr. Pugh?
A right angle, 90 degrees.
Oh, yeah. Oh, my goodness.
We do this. We do this.
Oh, my goodness.
This is what we do,
Now,
folks. Call us every Monday and Wednesday from 5 to 6. We answer all your questions, but no sticks. Okay, I'm stopping.
You did say this word before. What kind of lines are those?
Intersecting lines.
Do they make a right angle at all?
No.
No. They just crisscross.
They jump. Okay, they crisscross.
Jump.
Crisscross to make you.
Cross. Okay. And tomorrow, I don't want to give away our lesson too much, but we're talking about these kind of things. You know what's interesting about a right angle, Mr. Pugh? You said 90 degrees, but this is not called a left angle, is it?
No.
It's still what?
A right angle.
So does it matter which way it's facing?
No.
It
can be upside down, sideways, tilted to the side. If it has a 90-degree angle, it's going to be a right angle.
And we're going to use protractors, because protractors get a chance for us to measure the angles. And right there in the middle, you know what that number is, right, Mr. Pugh?
90 degrees.
90 degrees. And all the way halfway around, that's going to be a 180. Just like people on their skateboards doing 180s and all kinds of cool things with their bikes and stuff. And watch the Winter Olympics coming up in a couple weeks, and you'll be seeing
What you teach again?
Winter Olympics, and they'll have skaters out there on the ice doing 180s and 360s.
Yes, the quadruple laxus and stuff like that.
Oh,
I like
my
that.
goodness.
I watch it, yes.
I like that.
I like
my
that
gosh,
too.
you're great. Hey, we ready to pick a winner? I don't know.
I'm asking one question.
Yeah.
You don't do rays or
We do rays. Did rays.
Supplementary angles and.
We haven't gotten supplementary yet.
Oh, okay, I'll be just.
We will complimentary and supplementary. I think we're going to hit that too. But definitely rays and lines, line segments. Yep.
Okay, so it's time for the winner of today's show. And it cannot be me. I'm jealous. Can't you see? My last name starts with a P. Coming to you live from Prince George's County, where Devin Wills is a high school senior at Roosevelt. And the winner is Rose.
Rose. Yes, Rose. I think she's great. She deserves
and
that
remember,
call.
you can always watch us every Monday and every Wednesday from 5 to 6 until our last show of the year, probably middle of April or May. And remember, we have an elementary show from 4 to 5, secondary from 5 to 6. We love to have your phone calls. And you can always
count on us. My man.